Statistical process control. So in this, we will go through how statistical process control work and its belief systems where prevention rather than detection is better is one of the belief system. Inspection and charting process control, how it is done, as well as samples to be used with statistical data, gauge the products being made. Also, we'll take a look at what are the different process variations. So first, statistical process controls. Statistical process controls give emphasis to prevention rather than detection during manufacture and aims at achieving good quality overall. It usually controls the processes that makes a product. By process, it is meant the machine which makes the product. If the process is bad, the product remains bad. If it is good, the products are also good. It can, however, be not told universally because many a times good process does create bad products. But in majority of the case, this does not hold true. So the process or machine is inspected which makes the product rather than inspecting the product at first glance. This would also mean that the management has to take a proactive approach in considering inspections of the process and charting process controls before the event or the risk event, as opposed to inspecting the product after the risk event. Hence, SPC charts, which is statistical process control charts, are taken to be much like the temperature gauge of a car, where temperatures are in the green zone, everything is all right. But if it touches the red zone, one has to stop and inspect the vehicle. SPC in no way is the best answer for total quality. This is because, as was told earlier, a well-designed process does not guarantee the best available product, which would mean it may conform to all manufacturing requirements, but still fail to gather customer satisfaction for a quality product that is manufactured by it. Measuring products is a better approach in knowing whether the process which is supposed to produce the product does so in the best possible manner. The recommended way is to take samples of the product being manufactured and judiciously use statistics to judge the overall working of the process that makes the product. This is the gist of statistical process control. Hence, in reality, in SPC, it is the process which is getting examined and not the product in a more generic way. SPC is undertaken in such a manner that charts are used to plot the performance of a process. If the process behaves erratically, it is stopped before many defective components are manufactured by it. Next is process variations that are natural. According to Deming, every process has a natural variation. In other words, it is impossible to make a product with 100% consistency. The consistency variation may be because of a material's wear and tear, due to positioning of the material in the machine, speed variations that are seen to occur in the machine, actions of the operator being not consistent, etc. So these variations are called common variations and they can be statistically measured and its spread can be tracked. The spread of variation is also called as normal distribution, irrespective of which processes creates the variation and irrespective of the type of process, so long as the samples follow a pattern. The special events that follow get assignable to unexpected changes or risk events, which produces defects overall. So it is said 99.7% of normal variation takes place within 3 standard deviations or within the bounds set by 3 standard deviations. Standard deviation again is a measure of this spread and every normal deviation is said to have attained standard deviation. Usually the natural variation which is occurring within the upper and lower bounds or control limits between +3 standard deviation and -3 standard deviation is normal. Anything that happens beyond, the process needs to be stopped and inspected and may give rise to a special cause condition or unusual event happening in the case of statistical process control. Next, we'll take a look at what are the different charts which are used in statistical process control. So there are mainly two types of charts which are used in SPC, which are variable chart and attribute chart. Variable chart is a chart which measures a characteristic which is a value to scale, such as length of unevenness or number of scratches on the finished product. The main variable chart is the average and range chart. So average chart is again called as X chart. Range chart is R chart. So those are the two types of variable charts. In other words, the former measures, that is the X chart measures the average of the samples taken, and the latter, which is R chart, measures the range of the samples taken. Usually both of these charts indicate whether the process is in control, and if it is in control, the work progresses. Otherwise, the work stops and investigation on the process variation starts. An attribute chart is used to indicate possibilities which are pass or fail, yes or no, etc. With an attribute, a judgment is made on the outcome rather than a measurement taken from an outcome. So that is the difference. Next, it is attribute charts. So attribute charts are of three types: P chart, C chart, and U chart. In comparison to variable charts, with attribute charts, only one chart needs to be plotted. As far as the basic concepts are concerned, even in this type of chart, variation control, sampling, as well as setting and interpreting the charts and its results remain the same, but the formulae differs. Now first we take a look at what is P chart. P chart are percentage charts which are used when there are batches of products in which percentage of defective products can be determined. So here we have got a P chart. Now what is a C chart? A C chart is used to monitor the number of non-conforming features per product. Examples may be the number of scratches per tabletop, number of errors in a document, etc. In such a case, percentage figures are meaningless, so the P chart cannot be used. For using a C chart, the number of units sampled should be the same, and the control limit for a C chart is given as C plus or minus 3 SC, where C is the average value per sample. So if the average number of scratches per tabletop of 10 samples is 16, the control limit in a C chart are at 16 plus 3 into 4, which is 28, and 16 minus 12, which is 4. Hence, the control limit is found out by first finding out the average, then take its square root and add 3 times the square root to the average to give the control limits. Lastly, it is U charts. U charts are used to monitor average number of defects in a sample, and it is found out by control limit formula U plus or minus 3S into U by N. So those formulas we can actually add it in a subsequent session, or in a document we can actually add it. So all those formulas will be given to you. Problems with SPC. So problems with SPC. The following problems, limitations and assumptions exist in the case of statistical process control, namely risk. That's the first problem. SPC sometimes tell that the statistical distributions are out of control, when in fact it may not be, as well as says a process is in control, whereas in actuality the process may not be in control. This is generally termed as alpha risk and beta risk respectively. With increased capability, these risks are supposed to decrease. Also remember, the control limits are set up at plus and minus 3 standard deviation, corresponding to 99.7% of its full distribution. And so when the capability ratio is said to be at 1.0, the risk is 0.3%. or will be producing 3000 parts per million or ppm. Next is independence with samples. Independence between samples is also a much contentious assumption, since if there is a machine wear and tear, the samples will not be independent, and sampling between regular intervals also may not be independent sampling. Lastly, it is out of control conditions. For detecting out of control conditions, there are several tests employed. On an average, if samples are taken once per hour, it may take at least 7 hours to detect an out of control situation. Thank you.